Hello everyone and welcome. In this lecture we will build a logistic regression model and compare our result with the multinomial naive Bayes predictions that we did in the previous lecture. The first thing we'll do is import logistic regression from scikit-learn. So from sklearn.linear model linear underscore model import logistic regression, and once we import our model we'll instantiate our logistic regression model, and I'll save it in a variable called log underscore model, and that will be equal to logistic regression. And we'll do the same thing as we do with other models. Once we instantiate our model, we'll fit our model with our training dataset, in this case our X-train documenter matrix and Y-train datasets, and after that we'll use the predict method to make predictions off of our model. So next we'll take our instantiated model and then call the fit method and pass the X-train documenter matrix and the Y-train. So we'll be training our logistic regression model with the training datasets, and once we train them we can call the predict method and we'll save our result in a variable called Y prediction 2 to distinguish it from our previous Y prediction for the multinomial naive Bayes method. So our Y prediction will be equal to our logistic model that predict, and then we'll pass our X-test documenter matrix object. Now that we have our prediction, we can call the accuracy score method and print out the accuracy score. So let's print matrix dot accuracy score. We have already imported matrix in the previous lecture, so print matrix dot accuracy score, and then we'll pass our true result, true value Y test, and our prediction Y prediction 2 in this case. Okay, Y prediction 2. Now if we run this, we get an accuracy score of 97.9%, right? With the multinomial naive Bayes method, we had an accuracy score of I think 98%, close to 98.1. Let me print it. Y test and Y prediction. Run it. So 98.08, almost 98.1% accuracy score with our multinomial naive Bayes method model, and an accuracy of almost 98% with our logistic regression model. Okay, so you can use more than one model to distinguish whether a message is a ham or a spam, and if you get almost a similar result with two different models, you can use the faster model. So in our case, the multinomial naive Bayes model is faster than the logistic regression model. We can also print out the confusion matrix result. So print matrix dot confusion matrix, and then we'll pass our Y test and then Y prediction 2. So that will print out the confusion matrix for our logistic regression model. So here we have our true negative, true positives, false positive, and false negatives. We have 29 and 6. With our previous model, if we print the confusion matrix and change this to Y-pred, we had 24 false negatives and 8 false positives versus 29 and 6 with our logistic regression model. One thing I want to show you is how we can print out those false positive and false negative values. How can we distinguish those? So for that, let's say we have our y-test, right? This y-test represents the actual result. And if I say y-test less than y-prediction, what does this mean? Y-prediction. So for our case, spam or ham, it could be either 0 or 1, right? And the only case where y-test will be less than y-prediction is if y-test is 0 and y-prediction is 1, right? And if you remember, we assigned ham labels as 0 and then spam message as 1, right? So in this case, it will be a y-test value of 0, which is the actual value is ham, the actual message is ham, but it's predicted as spam. So if we index that, let me show you. If we take our X-test dataset and then index this, where y-test is less than y-pred, and run this, this will give us the false positive ones. These are all the false positive messages, where the actually they are ham, but they are predicted as spam. So this represents the false positive. Similarly, for the false negative, all we have to do is convert the comparison sign to greater than, right? So in this case, y-test, the only time y-test will be greater than y-prediction is when the y-test value is 1 and y-prediction value is 0, right? Since we only have those two values, 1 and 0. So 1 is spam, so the actual message is spam, but it's predicted as ham, right? So if we print this, that will give us all the false negatives. So if we copy this and then try to find the length of it, so this will give us the length of our false negatives, which is, if I go back here, our false negative is 24. We have 24 false negatives. Run it, we have 24. And the length of this false positives is, the length of this false positive is 8. Right? 1, 2, 3, 4, 5, 6, 7, 8. Which is here in the confusion matrix. Right? And then we can take a single message, a single row, and then see why, it was inaccurately labeled as either a spam or a ham. So for instance, you can take this 731 and then index it here, X-test 731, and run it. So this is the message, email alert from this person. It goes on like that. So you can further analyze this and try to see why it was inaccurately predicted as either a spam or a ham. And we can use the same methods to find out our false positive and false negative values for our logistic regression model. So basically we do the same thing, right? We do the same exact thing, except we'll use y prediction 2, right? We saved our predictions in the variable y prediction 2. So I'll change that to 2, and let me remove that. So if we run this length of our y prediction 2, that means length of our false negative. For our logistic regression model, the length is 29. And here, if we run this, we'll see all those 29 messages, which are false negatives. And similarly, to see the false positives, we just convert this to less than, and that should give us, how many false positives did we have? I think 8. Well, we have 6 false positives, right? we have 6 false positives. So if we run this, we need to change this to Y prediction 2. Run it. We have 6 false positives, and we can see all those messages by simply indexing our X test dataset, and we can see all 6 of those. Okay, so that's how we can compare different models and try to analyze the false positive and false negative results. Okay, thank you everyone, and see you at the next lecture.